Hello class, Mr. Anderson here. In this video we're going to talk about the classification of matter. So up at the top we have matter. We have a definition. The definition of matter is anything that has mass. Mass is something that we can measure, right, and takes up space. Those are the two requirements to be matter. Has mass and takes up space. Takes up space means that it has volume, right? Mass is something that we can measure. Right? We'll use our balances, we'll take out our scales, balances, and measure the mass of different objects and substances all year long. Okay? So that's a simple definition of what matter is. And matter is anything and everything just about in the universe. Right? If you're not energy, then you're matter. Right? This board is matter. We're made up of matter. The air that surrounds us is matter. Right? So matter is very important. It is what we study in chemistry, matter. We're going to study how it's made, how it's put together, right? The atoms, the molecules that combine to make up matter. We're going to talk about the changes that it undergoes, both physical and chemical changes or reactions. Okay? So all throughout the year we're going to talk about matter. But today we're just going to go over the classification of matter. So we have matter at the top. This is called the matter hierarchy, or sometimes the matter flow chart, because it kind of looks like a flow chart, right? But here it is. Matter can be one of two things. It can either be a pure substance, right? Or if we take our pure substances and we put them together, we mix them, then we make a mixture, right? So we can divide matter either into a pure substance or into some sort of mixture of those pure substances. Now, pure substances can be one of two things. Pure substances can be an element, right? And the elements you can recognize. Some you're very familiar with, right? But all of them are on your periodic table, right? So elements can be recognized because they are on the periodic table. A couple examples of an element, one that I know you're familiar with, is carbon. Carbon is a very important element, one of the basic elements of life, right? Has a chemical symbol C, right? Another important element that I think you'll recognize is oxygen, and oxygen has the chemical symbol O, right? So your elements are pure substances, right? The other type of pure substance that we have is something called a compound, right? And compounds are simply elements that have chemically combined, right, come together to form compounds. Right? Some familiar examples of compounds include water. Right? We're all familiar with water. And the chemical formula for water is H2O. H is hydrogen. We have two of them. One oxygen. They combine to form water. Right? So that's an example of a compound. Another example of a common pure substance that is a compound is salt. And when I say salt, I'm talking about the table salt, sodium chloride, the stuff that you put on your French fries. Right? That salt has a chemical formula of Na. Na is sodium, and Cl is chlorine, two elements that have combined to form a compound called sodium chloride. Right? So that is another example of a compound that is a pure substance. So the key to recognizing compounds is that there is a single chemical formula that you can write for it. Water, you write H2O. Salt, you write NaCl. So if you see or you can write a single chemical formula for that substance, that means it's a compound, and that makes it a pure substance. All right? So those are our two pure substances, either elements or compounds. Now, if we mix those pure substances, two or more of them, and we just physically put them together, let's take salt, right? Plain old table salt. Let's dissolve it in water, right? Putting two pure substances together. Now you have a mixture. And when you look at mixtures, there's two types of them as well. There's something called a homogeneous mixture, and then there is a heterogeneous mixture. All right? And to understand the difference between those two mixtures, we can look at the prefixes of those words. Homogeneous, homo, means the same. Heterogeneous, that prefix there, hetero, means different. right? And I know you've used those prefixes before in biology and in other places as well. So remember, homo means the same, hetero means different, right? And that's going to help us understand those definitions. So, a couple examples. Homogeneous mixture. That's when you take two pure substances and you mix them together. Let's think about the salt dissolved in the water, right? When you dissolve salt in water, you now have a mixture, and it has a very uniform composition. It is the same throughout. Wherever you go through that solution, you have salt and water, right? So the key words to defining a homogeneous mixture is uniform composition. Again, composition is simply what makes this thing up. That's the salt and the water. And uniform means the same throughout. All right, so our example of a homogeneous mixture is salt water. On the other hand, a homogeneous mixture is when you take two of these pure substances, two or more of them, you mix them together, right, and they're not uniform. Right? So we have a non-uniform composition. So one example of a heterogeneous mixture would be seawater. Right? So you can imagine going down to the ocean, getting a bucket of seawater, right? And you might be thinking, well, seawater is salt water. Right? We have salt dissolved in water. So that's homogeneous, right? Well, that's true, but are there other things in that seawater? And most likely, yes. If you take a bucket of seawater down at the beach, right, you probably have some sand in there, right? And that sand isn't going to be uniform, right? It's going to settle out at the bottom, right? So that's not uniform throughout. That's a heterogeneous mixture. Maybe there's some other things as well. Maybe there's some seaweed floating at the top, right? And it's not at the bottom, so it's not uniform, right? Maybe there's some sea life in there as well. Maybe you caught a fish in your bucket. Right? So that's an example of a heterogeneous mixture. And that's our classification of matter. Right? Just a quick review. Matter can either be a pure substance, which is an element, or a compound. And if we take two or more of those pure substances and we physically put them together, we have a mixture. If they mix uniform throughout, we have a homogeneous mixture. If not, we have a heterogeneous mixture. So we're going to use this information to help us classify some substances in class.